Well, okay, so I just finished up the stack, and now I'm going to implement the a queue. So it's going to look very similar. So I'm actually going to be kind of just copying all this and creating a new file for just, I think I'm clicking too much, queue, wait, I have to spell the word queue. Oh no. Okay, so that's how you spell queue, I think. Yeah, so let me just copy and paste this. So I'm keeping the nodes the same. They're basically not changing. The top this is where I'm going to have to like probably change things up a little bit. So I'm going to have Q and rename that. I'm just going to like kind of just get rid of this for a second. And there are a few implementations. I'm actually going to just straight up delete everything from here on. So that stuff is just gone. All right, so the idea is that isEmpty is still kind of valid, and the peak is also the same thing. So I'm not sure if I want to use the word top. Maybe I'll call it first, because it's like the concept is a little bit different. So I just want to be explicit with my naming here. So first.val. So let's see if this works the same way. I think returns true if the queue is empty. All right, and the first is equal to null, and that's the case. Yes, peak returns true. Top returns first value. If first, then return the value. Otherwise, just return effectively null. Okay, cool. So this works as expected. Maybe just create some test cases just to have it. New queue. And I believe I don't. Yeah, I construct with nothing in there, so that's fine. Let me just like shrink this too. And then I will do console.log q.first. Okay, so when I run this, it should just say q. It should just say null because I haven't done anything with it. Okay, cool. So let's think about two more methods that should go along with this. The first one is to add an item, of course. So this is similar to the push, but add is a little bit more appropriate, I guess. So this just adds to end of queue, and that is a very important distinction between that and just adding to the top. We'll find out this is actually a little bit trickier in the sense that you have to kind of traverse the linked list all the way to the end in order to add to the end. So there's some time considerations there implementing this. So you have add and you have remove, of course, and this should remove the first item. First item from the queue. Okay, so and we'll find that this remove is very similar to the pop. So I can maybe copy some of the code there, but effectively that is actually I think that would be easier for a moment. So let me just try that out. Let me just do first equals new node, give it that value 5, and give it like one more, like 10. Oh no, no, let's not do that. And then I want to call q.remove. Okay, cool. So this should remove that first item. Remove. Wait, you don't remove item. You just remove, and it removes the first item by default. Okay, so here's where we have a little test or base case, because it's possible that the last item. Oh, I remember something. I want to remove it and return value. So that's another thing. Yeah, so I'm removing it, return value. So I kind of want to store. I want to store that node, the first node. So this is the dead node again. This dot first, and I want to store the value equals this or dead node dot val, and I want to return val at the end. And I guess I can't delete it explicitly. I still haven't looked up what the strict mode problem was. I think it's something with ES6 probably, how the namespace, especially if you're using the word const, the keyword const, I think that's probably doing something that I didn't want it to do. But anyway, I'll check that out later. Yeah, so so here I'm gonna put some comments. So store value, store node and val. All right, return val, and I need to handle, I need to exchange nodes for first. All right, so the first should look like this, and what's nice here is this dot first is literally just this dot first dot next. You know, if that next value is null, then you're fine. If it's another node, then you're also fine. So this is actually all you need to do. I will say that I prefer, so I don't know why I keep doing. Do I even need this? I don't, probably not. So I'll just say I'll handle leaky reference, and I want to say dead node dot next equals null, just to kill it 100%. I think that should work. So let's run this code here, and I returned. So remove. Yes. So okay. So so I added the node. I removed it, and then first is now null. So I'm going to actually add that here, and then see it in both places, I guess. Okay. So first I added it. It's this node, and I should console log this too, because I want to see that it properly returns the value that I popped out. I removed, I guess I should say, which is 5. Okay, cool. So it's working as intended, it looks like, and it takes into account the case of the next value being null. So it will. Now I'm thinking, what happens if remove does? What if you try to remove on an empty queue? And I need to think about that. So what if I try removing again? Right, I'm gonna get an error, I'm sure. So yeah, right. Yeah, I got an error. So I need to check. Yeah, there's no value there. So I need to check. So if this dot is empty, then return. Yeah, okay. There you go. So that's just a double check there. Let me. And it does exactly. It returns undefined. Maybe I want it to return something else though. Well, undefined was not a value. Okay, if I'm returning values, so the actual value could be literally anything. So maybe I want to return null. Is that really what I want? I don't know. Because I want to be consistent. Because technically, you could store the value undefined in your queue. Maybe I'm thinking too much about it. Whatever. I could think more about this, but whatever I want to return, I want to be really specific about what I'm returning and what kind of information is how data is flowing through this system effectively. But I'll just say return null just to be consistent with my use of the word null, and that should be okay. All right, add items. Sure. So let's do add item. Val. I should say val. And add items at the end of the queue. So here we need to traverse the linked list effectively, list, and add to end. And that is it's relatively simple to do, but this is a consideration. Whereas before with the stack, you can just add it onto the top. That's constant time. There's no real work that you need to do there. And depending on your situation, maybe that's preferable. But if you need to have a queue system set up, then you have to keep that in mind. So if we traverse, we have the current so this is the let current node equal this dot first, while cur dot next we can. So this is saying the current is the first node while there is a dot next, and I think I have the same situation as before here where I need to just in case it's empty, we gotta take care of that situation. So if you're empty, just return null. Yeah. Wait, no, don't return null. What am I doing? If you're empty, this is the one situation where you need to just say this dot const new node first of all equals new node with the val. If it's empty, then this dot first equals the new node, and you are done. So I could return there. Do I want to return? That's it. Return nothing. Return. Yeah, it shouldn't. This function shouldn't return anything, right? Yeah, it's fine. Okay, so in the one rare case that it is empty, then this is handling it. Otherwise, we have a dot next, which allows me to do this call. That's the reason I had to add that base case in. And while there's a next, then we just say current equals cur.next, and we get all the way to the end. And at the very end, there will be no dot next. That means the current is the last element, and that is where we add our new node. And I return nothing because it's doesn't need to return anything. Okay, cool. So now, oops, I need to go to the bottom here. So now here I should be able to do q.add, q.add 5. I'm gonna add a bunch of stuff like 10 and whatever that number is and that. Okay, and then I want to, what do I want to do? I want to just like view it, I guess. Dot first. So I should be able to follow the string, the list of it. So yeah, I got the, so this is exactly how the queue works. It's in the exact same order that I put it in. It's 5, then 10, then 345, and this one is like shorthand, but it's effectively saying, you know, the rest. So the idea of last in, first out. So I'm going to pull up this stack first. So this is a last LIFO, last in, first out, first out situation, and the queue has a FIFO, first in, first out situation, and those are how you implement them. In the book here, they have a scenario where when you remove on an empty list, it will throw an error. You know, that makes sense. I definitely would not be against that. There's something I have that, yeah, so I kind of talked about this, like, I don't feel comfortable doing this return of null, so actually I think that might actually be a proper solution. So that kind of elegantly resolves the issue. If a user tries to use this improperly, then I'm going to hit them with an error. So I'm going to throw error. List queue is empty. Bam. Okay, cool. So just one correction I need to make, and I did it in the stack video as well. There's an issue here that I threw the error at this point, but the same thing could happen here with the peak, because right now I'm returning null. In this case, when the value is when there's nothing in the queue. But technically you could have a node with the value null. That is totally valid. So to be less ambiguous, I want to actually throw an error here as well. So I'm just going to copy this and throw that up here so that it actually is explicit, like, hey, the queue is empty, and this is not me returning null, the value. I'm returning, I'm throwing an error because you did something improper. So I can delete this and just have it return the value now that I kind of take care of that base case there. And that is my implementation of a queue more properly. Hope that was helpful. I hope the clarification was also helpful. And I'll see you next time.